Thank you for watching Hack the File. I'm Michael Lopez, and today we're going to do the next video in the Ethical Hacking book series, finishing up Fuzzing. Enjoy. All right, so we're back. I got really busy with work, so I had to skip a week or two on making videos, but hopefully made you guys want to watch these videos. I also took a week off. I was trying to hack this website um, for a company that basically said if you hack their website, you can get an interview and all that stuff or whatever. But to give you permission to hack it is basically what it was about. And so I was trying to hack that, on my free time or whatnot. And I was trying to make videos of it, but I mean, I was hacking it for about 10 hours straight. So I mean, off and on. So there's a lot of video, right? And I hacked it once when I wasn't recording, and then I just completely forgot how I did it. I mean, I must have got lucky or something. I was changing values and variables and all that stuff on the website. But anyways, so it's harder than you think to actually capture the video of doing it. But I'm gonna continue with that on my spare time, and if I can do it, then I'll upload the video, and because it's pretty cool. But for now, we're just gonna do finish up the ethical hacking book series. It's getting really interesting. We're gonna get into like antivirus bypass and stuff like that after a while. So, well, we're gonna pick up today on fuzzing. So, all right, here we go. All right, fuzzing. How do hackers find bugs like heartbleed? And this was on the last video. This is fuzzing continuation. So, if you want to know what that is, watch the last video. As you just saw, the process of exploiting this bug is so intricate that it's amazing to anyone. It's amazing anyone could possibly discover it using efficient means. There's even an entire team of Google called Project Zero, dedicated to finding zero-day vulnerabilities. And this, in case you're interested, the team posts new vulnerabilities they discover on its blog. All right, let's click on that blog and see. So here's their blog. You can go to pause it and go to this website. I'm not going to read that blog. Actually, let's see. Do I already have that saved? I do. Let's discuss some of the tools and techniques attackers and security researchers use to discover bugs like heartbleed, beginning with a testing called fuzzing. Fuzzing techniques attempt to generate inputs that explore all the possible paths in a program in the hopes of discovering one that will cause a program to crash or exhibit unintended behavior. That's basically what I was doing to this website when I was trying to hack it. Fuzzing was first proposed in 1988 by Barton Miller, a professor at Wisconsin. Since then, companies like Google and Microsoft have developed their own fuzzer tools for fuzzing and use fuzzing to test their own system. How many times we can say fuzzing? Fuzzy Wuzzy was a bear, Fuzzy Wuzzy had no hair, Fuzzy wasn't really fuzzy, was he? Alright. A simplified example. To understand the basic concept behind fuzzing, we'll begin by considering the following example function, originally proposed by Jeff Foster at Tufts University. So you can go ahead and analyze that. As you can see, the function accepts three parameters, A, B, and C, and it is considered to have executed correctly, as long as its internal variables x, y, and z don't add up to 3. If they do, the program's assert statement which for the purpose of this example represents a critical failure, will be triggered. Right, so there's the assert right here. If not C, those and this. Our goal as fuzzers is to cause this failure. Can you identify the parameter values that will cause the assert statement to be triggered? One way to determine which input triggers the assert statement is to visualize the path through the program as a tree. Every time we encounter an if statement, the tree branches to represent two possible options. Which one of the branch is taken and one in which it isn't. Figure 9.5 shows the path and the preceding function. So they just basically made a little tree here saying that if this is true, this will happen. If that is true, this will happen. If that is true, that will happen. If not, this is basically just a logic tree. One of these paths triggered the assert statement. Consider what would happen if we supplied inputs of 0, 2, 1 for A, and B and C. In Python, 0 is equivalent to false, where non-zeros are considered true. Trace the path that the input takes to the tree. Notice that this path sets x to 0, y to 1, and z to 2, which triggers the assert statement. That's fine. So this is going to be just deep into the programming logic. Writing your own fuzzer. We had no trouble discovering a harmful input in the last example, but in larger programs, there could be millions of unique paths. Exploring it by hand would be difficult. Could we write a program to generate test inputs? One approach would be to randomly generate inputs and wait for them to execute all paths in the program. This technique is called random fuzzing. Let's write a basic random fuzzer. Our program will generate random integer values and pass those values to our test program's parameters. Create a new file called myfuzzer.com. No, wait. myfuzzer.py and add the following context. Okay, let's see if we have this so we don't have to add this. Okay. Right. So it's going to say, let's look and see if we have that here. So myfuzzer.py is right here. Okay, let's copy this. And we'll go to, let's see if my, yeah, it's running. Alright. Let's let this load up. Go to my HackTheFile. Let's see if there's any fuzzer file. I don't know if I've done this before. I feel like I've read or done this before, but it was probably just the first fuzzy one. So I don't have any fuzzing file. Well, let's create a folder. Call it fuzzing. Right. Then we'll put that in here, and we'll create a document. We'll call it what? My fuzzer? Is that what he? .py. Remember, .py is that Python file, right? And we'll open that, and we'll just paste this in here. This doesn't always work, right? Um, you have to. Sometimes you have to reorganize these codes because the way they get pasted in here. But sometimes they work. So, all right, we already did that. So let's go to the next one. And remember, the reason why I'm doing this is because I'm creating a hack the file from this book. Um, um, Different things we can do, right? So my wireless hacking, go to instructions, and it's got some commands I can run. Right, just give me some little ideas, just in case I forget or something. Right, get me started. Um, so let's go back to the fuzzing. Oh wait, there's heartbleed. Well, yeah, here's heartbleed. There's no instructions. It's just a pie. And here's fuzzing. Okay. All right. Let's continue uh, with the book. All right, we already did this. Copy the test. Copy the test function. This test function shown earlier into the file. One. What? Place test function here. So where's the test function? Oh, right here. Def test function. Copy this test function. Do we have that? What's an example? Let's see if they put that in. See if they put that somewhere right here. Yeah, right here. Look. Wait. Right here, dev test. See, nah, that's a different one. So we're gonna have to write that, which sucks. So I'll pause the video. I'll write it into there. Like place test function here. Oh yeah, this is the example. Oh, my for example. It's a different test function. What is this? Where's heartbleed? Do we have to place a different test function? Yeah, okay. Earlier. To understand the basic concept of a world centered, for example. Simplified example. Dev test function. Copy the test function. Test function method. Let me see. That's dev. Oh yeah, yeah. Test function method. Okay. All right. Wants us to put that in there. Okay. Let me just. I will. Our simple fuzzing program generates a random integer for each input variable. A equals random. Yes. There it is. Once we've generated a random value for each variable, we put the input to the screen. Okay, we print the input to the screen before calling the function we're testing. Save the file and then run the fuzzer using the following command. The fuzzer will cycle through random values until it finds one that stops the program. What program though are we going to be running it against? That's weird. Is it I don't know if we're going to do that. That's stupid. Experiment by increasing the range 200 400. The more random numbers the program needs to be. Discover an input that crashes the program. This is one of the disadvantages of completely random fuzzing. You'll need to cycle through many benign inputs to discover a useful one. Later in this chapter, we'll look at ways to address this issue. You might be wondering, is generating inputs that crashes a program really this useful? Crashes are the first step to discovering bugs, which attackers can often exploit, but generating data that crashes a program can be very useful in its own right, too. If you can get an application to crash, you could execute a denial of service DOS attack. Imagine if you could discover inputs that crashes the Google DNS server or cell tower. That would be pretty valuable. Or consider the following scenario. A hacker has fuzzed an intranet connection traffic light control system. Surprisingly, such devices are common. The hacker discovers some input that crashes the system, thus disabling all the traffic lights in its control. They've now discovered an input sequence that will allow them to disable traffic lights at will. This is very dangerous and is an excellent reminder of why it's important for ethical hackers for penetration test systems two penetration test systems before they are deployed. American Fuzzy Lop. Okay, so um, let's do this and see what happens. I have no clue what's gonna happen. So let me pause the video. I'm gonna input this real quick into that Python program, and then we'll run it. All right. So I put God, what's that beep? Stupid. Anyway, so I ran the program a couple times. I had to fix it, but I got it to run. Let me see if I can pull up. Oh, man, what's that freaking noise? So I got it to run. Let's see. Let me show you what I did. So we'll come back here. All right, like I said, I just added this little test fuzzer, and what's gonna happen is it's gonna run these random numbers, and then it's gonna until it breaks or crashes on this assert right function, and then it's gonna print it out and say it crashed. So I mean I already ran it just to test it. So we're gonna run it again. So Python 3 myfuzzer.py, and let me do this again real quick. So what I do is for a shortcut, instead of command lining my way back to where this is at, just open this up and open a terminal here, right? That way it's gonna I don't I could just do it there since I'm gonna open a terminal somewhere. Why open it on your desktop and then command line over here? This is ridiculous. I'll open up a terminal there real quick, and then I'm gonna do the Python 3 myfuzzer.py because that's what it said to that's how you run it, right? And we're gonna run this, and as you can see, it ran a bunch of different numbers, right? Until it crashed. So line 25, where it gets here on your main, line 21, test function A, B, and C, line 12, assert, and then that's where it crashed, right? And then it printed out assertion error. So it was running through this while true, printed out A, B, and C, and that's what it was doing here, 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 test function A, B, and C, or whatever. And then it came to, it crashed. And so that worked, right? All right. So that was pretty interesting. So now let's go to um, back to our book. All right. American Fuzzy Lop. Simply generating random inputs seems a bit wasteful as a larger search will take longer to fuzz. Couldn't we use information about the program's path to generate more focused, carefully crafted examples? Well, certain fuzzers instrument a program by inserting instructions that log the paths to the program takes when it executes. These fuzzers attempt to generate new inputs that explore previously unexplored paths. Given a set of pre-existing test cases, they'll mutate the inputs by adding or subtracting some random information, keeping the new test only if they explore new paths in the program. Their American Fuzzy LOP, I don't know if that's LOP, AFL is one such fuzzer. Originally written by Michael Zalewski at Google, AFL uses a genetic algorithm to mutate test cases and create new inputs that test unexplored paths. A genetic algorithm is a biologically inspired learning algorithm. It accepts inputs such as A equals 0, B equals 2, and C equals 1, and then encodes them as a vector, similar to a sequence of genes in someone's DNA like ATGCT. Armed with these vectors, the fuzzer keeps track of number of paths explored when the program uses a particular input sequence, say 0 to 1. Genes that are similar will explore similar paths, thus reducing the likelihood of exploring a new path. The fuzzer creates new genetic input sequences by introducing randomness to the values of existing sequences. For example, the input sequence 021 may become 401. Here, the genetic algorithm chose to mutate the first and second elements by randomly adding 4 and subtracting 2, respectively. Genetic algorithm implementations often allow programs to choose how often mutations occur and whether to make large or small changes. The new sequence is then fed to the program. If the sequence explores a new path, the input is mutated, and if it doesn't, it is deleted or mutated. There are plenty of other mutation strategies that you can explore. For example, crossover mix sequences from two genes to create a new gene. You can read more about genetic algorithm in John Holland's original paper, Genetic Algorithm and Adaptation, Adaptive Control of Ill-Defined Systems, 1984. So that's pretty cool. Um, if you're a programmer, then you could probably try to make one of them little algorithms, right? Installing AFL. Let's run AFL to discover an input sequence that causes the test function to crash. You can download AFL from Google's official GitHub page. Clone the AFL repository by running the following command: git clone https github. Okay, so let's go ahead and do that. And what we can do is we're gonna we're gonna run. Well, where do you have to put it in your home or where? Yeah, let's do it in my let's do it in here. All right, git clone https github.com/AFL.git. All right. Now we're in the AFL. All right. So now it says next navigate to the AFL directory. We just did that. Compile and install the program by running the following command: AFL, make and sudo make install. All right, let's do that. So, um, AFL money make and sudo make install. Oh, so what command did I? So I think it's just this. Make. I might need to wait. Right. Oh, oh. Make and sudo. Which command is not found? So I was already in that AFL. I don't know why I was putting that right there. That makes sense. Yeah, because I went to the AFL. This is if you're, I don't know, if you're not in it. Yeah, man, give me 1 second. And looks like that worked. Yeah, because I was already going off of doing it from a different path. So make and sudo make install once you're in that AFL directory. All right, let's go back. Oh, let's go back to here. Let's see what else it wants us to do. AFL was originally designed to fuzz C and C++ programs. AFL's instruments AFL instruments these programs by compiling the source code and instrumenting the binary. We won't be fuzzing C programs, so we'll need to install Python AFL, a program that extends AFL's functionality to Python's programs. We'll use pip3 to install the module. If you don't already have it, run the following command. I already got pip, but we're going to run it just in case. Take this back over here, and then we'll bring my thing back up. Come back here. And run that pip3 just in case, even though I think I already have it. But this might be a new VM, so I don't know. Okay. but it's always good practice, right, to do it. So sudo pip3 install python 3 pip. No versions found for Python 3 pip. Could not find. Oh, wait a minute. What did I do? Yeah, I did something wrong here. Sudo apt-get. Yeah, so it already is the newest version. So yeah, I forgot to put the apt-get in there. Then install Python info. So sudo. Oh, yeah, I was looking at the wrong one. Sudo pip3 install Python. Man, I really jumbled that up. Python AFL. Alright, so now it's downloading that. We're gonna successfully build warning running pip as root. Yes, we know. Alright. Let's go back here. Now that you've installed Python AFL, let's use it to fuzz the shit out of the test function. No, I'm just kidding. Let's use it to fuzz the test function. Create a new desktop folder called Fuzzer. And within the Fuzzer folder, create 3 folders called Test Input, App, and Results. We'll store our test files in the Test Input folder and the results of our fuzz in the Results folder. We'll store the code for the app that we want to fuzz stuff in the App folder. Okay, so what we're going to do is we're going to modify this just a tad bit because I'm going to customize it to my liking, right? So what we'll do is, okay, so we'll go to HackTheFile and instead of my desktop called Fuzzer, it's called HackTheFile. No, let's just do everything, this test stuff, let's just do it off of a, well, no, because it's going to want the program. Yeah, let's just run it on my desktop, and then I'll delete everything. That way it's easier. Because it says on the desktop anyways, so I'm going to just make it easier for myself. And I'm going to just follow the directions. Fuzzer. Okay, so here's Fuzzer. Within the folder, create 3 other folders. Called test input then another one called app, and another one called results. All right, we'll store our test inputs in the test input folder, the results are in the results, and we'll store the code for the app in our app. Okay, so that's good. Let's come back here. All right, modifying the program. The Python AFL fuzzer assumes that test inputs are read in from a file supplied via stdin. So we'll need to modify the program to do so. The following program reads values for a, B, and C from a stdin, which are then converted from strings to integers and passed to the test function. Create a file called fuzzexample.py in the app folder and add it to the code. So now we're going to go to here, and I think it's my wait fuzzexample.py. That's this one right here. Okay, so we're not going to write all this. It just takes forever. Copy that. We just have to print it and then we'll modify it. So we'll go back to our Kali box, go to app, create document, and it's going to be what? What was it called again? It's called fuzzexample.py with a little f. Okay. Fuzzexample.py. Open that. Paste. Save. Close. Okay. Open that back up. Okay. Create a file called and add the following code. Got that. Remember to copy the test function into the location specified by the comment. Okay, so let's get that test function. Test function from the last one. So that's what I'm assuming. So we'll go to show fuzzer, and we'll take hack file fuzzer here. Take this test function. Now we're gonna have to mess with this a little bit. Okay. Now that's in that. The test function from the last one's in here. We know that it worked because we ran it. Okay, now we're gonna go to here and see what it says. Remember to copy the test function to the location specified in the comment. Got it. Next, we read the contents of the stdin1 in string equals std.read. Then we strip trailing spaces and new line characters. Strip everything. We also split up the lines into three variables, A, B, and C. We're going to split them up, strip them, and split them. We instruct the AFL library to begin instrumenting the program by calling AFL int. Okay, hold on. We instruct the AFL library to begin instrumenting the program by calling AFL. Okay. Then we execute our main method before exiting. Here. Okay. It's good practice to call a OS exit so that you can quickly terminate the fuzzy run, but this isn't required. And it's not going to work. Watch. Creating test cases. Next, we'll need some test cases to pass to our program. Open a terminal and navigate to the fuzzer folder on your desktop by running this command. cd desktop fuzzer. We don't need to do that. You guys can practice that if you want. If you're at your home and you want to go to your desktop and your fuzzer thing that you created, you could do that. But like I said, I just go straight into the where I need to go. Fuzzer folder on your desktop by running the command. Okay, we're in the fuzzer folder now. Run the following command to create a test input one.txt file. Okay, so this one we're going to practice. In the test input folder that contains the values 0, 1, and 1. So we're going to bypass this. We're just going to go right into there and we're going to create that there. Okay, so we're going to go back. We're going to go to test input. We're going to create a open a terminal here. Now I've been creating files like just by right clicking, but that's more Windows OS ish. If you're in Linux, you're gonna want to practice this, so we can practice this. Okay. Now we're gonna use the echo, right? Echo 0, 10, 1. That's what we're putting into that file. Remember? Then we're gonna call it test input. Oh, wait a minute. We're already in there. That's where it's going. We're gonna just call it test input one dot text. So echo creates the text. This is the quotation marks. This is what we're putting in it. We're just gonna put a 0, a 10, and a 1, and we're not piping it, but we're throwing. Actually, I don't even know if you need to put this caret right here since we're already in here. Text input one. That's what we're calling it. So, anyways, yeah, you do got to put that in there. I don't know. You could try it. But yeah, there you go. And look, it's got the 0, 1, 10, and 1 in there. All right, so now we created that. So that's how you create it on the command line. Okay. Okay, now we're gonna redirect it to. Okay, so this is interesting. So let's read this. So now we've already did that. So now we're going to redirect by using the little caret. Redirect these values into the program by running this command. So we're going to skip this one, and we're going to go Python 3 app. Oh, actually, yeah, we can add this if we're. Yeah. Hold on, let me see. No. We don't need that, and then we're going straight off that directory. So Python 3 app Fuzzing examples.py, and we're gonna run these test inputs over there. Okay, so let's figure that out. Oh, we're in. Um, so we're in. Use a PWD tells you where you're at, right? So we're in Fuzzer test inputs. So we want to go to the app. We want to send stuff from this folder into here, right? So what we're going to do is we're going to say Python 3 app. That will be what did we call it? Oh, Python 3. Why is it Python 3? That's weird. Anyways, fuzz example. Oh, because yeah, we're running it. .py. I'm going to redirect it. I'm going to redirect these tests. Test input from test input. Is that what I called it? Yeah. From that folder. So I was hacked or something. I don't know what the heck happened, but um yeah, I got it to work. So I got it to run. Um I guess where I left off in the video, it was going from that folder to this folder. I don't know what was going on, but what I did was I looked at his directory and where he was doing these commands from. He was doing these commands from his fuzzer folder. So in here, so I went to that directory and then I ran that. So app fuzzing app.py. We're gonna pipe this test um, in there, right? And then it worked. So the problem is the line 122 wasn't working, right? Now it is, but it didn't capture it on my video or something for some reason, or maybe it did. I don't know. It's something weird happening. But we'll go back into the app, and so when I first ran it, this test function was too much over here somewhere indented. So it just ran into that problem. I back indented it, lined it up, and then now it's working fine. So, well, it appears not to be crashing or anything, but um, we're just gonna go on from here and read to see what do we got to do next. Okay, so we've got these inputs piping into, redirecting into our application. If you've done everything correctly, your program should run without printing anything. Okay, that's what it did. If something does print out, read the error message and ensure that you follow instructions carefully. And that's what we did, but I don't know if that recorded it or anything, but that's ridiculous because that's weird. I'm gonna have to rewatch this. But anyways, create two additional test files by running the following commands. So we're gonna create these two test files, okay? And I'm gonna do them the like that. So let's go to yeah. So he's still in the fuzzer. So this is just practice on how to um, redirect these. So 257. We're gonna redirect these to test input slash test input one. Oh no, I'm sorry. I'm gonna create two dot text. Okay, and then we're gonna do it again. Change the values to 10. That's what he's wanting. So 10, 10, 10. I'm gonna put that into. We're gonna create one called test input 3. There we go. We'll come here, and now we've got test input 2 and 3. Okay. All right. We've created those. So fuzzing the program. Now that we've explored the code, let's fuzz it. Here is the general formatting for running the PyAFL fuzz program. PyAFL fuzz, your option, Python 3 path to fuzz app. Before fuzzing your Python program, disable the AFL fork server functionality. This performance optimization is problematic for Python AFL fuzzers, so run the following commands to deactivate it. So what we're gonna do is now we're gonna go like this. Okay, so we're getting into stuff that we can actually use. So I'm gonna come here and actually I'm gonna take this so I can read it. There's your little test inputs. Um, so we're gonna come here to hack the file. We're gonna come in our fuzzing. Don't get confused by this. This is just for me. Create a document, instructions. Okay, not text. I'm gonna come into my instructions and I'm gonna say, um, run export AFL no fork SRV equals 1. I'm gonna say comment this well, I'm gonna say disable this. That's it. And save that. Minimize that. And we've already ran that. So what we're gonna do is we're gonna take that fuzzing. Yeah, my fuzzer.py. We're gonna take this app, copy. I'm gonna paste that in there. Okay. Now we're actually gonna run that, and we're in. Where is he at? He is in his fuzzer. We're still in there, so we're gonna say export AFL no fork server equals 1. Okay, we ran that. Now we can fuzz the Python file by running the following command. Alright. So we're gonna say pi AFL fuzz I test input slash underscore results slash Python 3 app slash fuzz sample.py. Invalid option. Yeah. Output directory. Input directory. Did I not put the input in there? All right, we got a problem. Says AFL fuzz invalid option. Where's that at? Uh, Pi AFL fuzz input test. Let's see if this is wrong. All right, we got some issues here. Let's try this again. All right, so pi AFL fuzz. Let's try that one more time. Oh, it's telling me what? And for invalid option. So the pass to the Fuzz app is not right. That's the Fuzz example, right? We just ran this bad boy. Man, why would that be double? That's true. What is that? I already tried that though. Alright. You have two CPU cores, one runnable task. Try parallel jobs. Tempted to run. Do not instrument shop, but test cases. Useless one time. Two favored. The holiest. What happened? So let's see if that was supposed to work like that. So this says Python 3 test for, and here they have that double right there, Python. Yeah, something happened. Another error. Because I'm not getting this. I'm getting, it says you should see the follower screen, which should update in real time as the program is being fuzzed. Cycling. That's not what I'm getting. I'm getting something completely different. All right, this is it. Okay, so it's attempted to run. All right, there you go. It's too small. What in the holiest? Are these the different test cases? That looks more like it. Yeah, runtime. Yeah, it says yeah, processing time, cycle time, seed time, fuzzing. To find the inputs that crash your program, navigate to crashes folder inside results folder. This folder contains the input files that crash the program. You'll notice you'll notice inputs like an empty file and a file with invalid characters. However, you should notice a file with valid inputs that took the path discussed earlier, activating the assert statement. Awesome, awesome sauce. So, I mean, this is working. It's um, just running those numbers. Right, one, two. So this is ready to rock. Just where's the ones that say text one, text two, text three, level two? Too small to display it. All right, let's close this. Yeah, look at that. Crashes. 10 and 1 crashed it. Oh, I'm liking this. I'm liking it. This is awesome. So these are crashing the programs. Man, I'm just loving this. 0, 10, 1. Bitmap. Fuzzer stats. Damn. Bro, I'm loving this. All right. So we did that. Um, it's kind of a long video, so I'm gonna end the video here, and then I'm gonna pick up, and we're gonna have to do a third video on fuzzing, because apparently there's a lot to learn, right? And so what we're gonna do is we're gonna continue through this process. This all worked fine, and we got everything to work and everything to fuzz and run. Um, on our next video, we'll continue with this, and it's kind of a long chapter. Um, but I think that as we go through this chapter, right, um, it will kind of make more clear on what fuzzing is and what the goal of fuzzing is, and how to actually do it in the real world. Because I mean, this is kind of cool right here, like this ANGR program. Um, I mean, it wants you to learn it and do all it, and then it wants you to like see if you can use it to capture the flag on this guy's thing. So this is very interesting, right? and fuzzing web protocols and stuff. So I mean, this is a very interesting chapter, right? So I'm gonna tell you the truth. I'm not really clear 100% on how we're gonna use um, this fuzzing program, or how we can like manipulate it if we wanted to actually do some fuzzing with it, like at a job, or for curiosity, because you can take, I guess, the source code from open source is what it was saying, and take it and then try to fuzz it, and if you find something, you can bug or something which makes it crash, you can disclose it, and all that stuff. But we're not going to be able to do none of that because I'm on a virtual machine right now. I don't have any of this on my laptop, nor do I want to. Right. So if I'm ever serious about all this stuff, I can get me a badass laptop that I could do all this stuff for real on. Or if you're going to work for a company, I'm sure they're going to provide you with all the tools you need to be fuzzing and hacking things. So in this case, it's just to know of it and to get it to work, to actually have some kind of knowledge and practical experience with the fuzzer. You know, seeing how it works and stuff, right? But like I said, we're gonna have to go through here, and I can get a more clear um, idea of how to use this practically in the real world, and hopefully, when we get to this chapter, I'll have better answers. Okay. Right now, it's kind of fuzzy. So, in the next video, we're going to do symbolic execution, and we're going to finish this chapter up and move on to the next chapter, which is building Trojans, right? And hopefully, this one's really cool. Um, but that's what we're doing. So, for now, I'll see you on the next Hack the File. I hope you had fun.